Hello everybody, how are you all? I hope so you all are doing well. Myself Sunil Pawar welcomes you back for the new session of 10th class science subject. As you know that we are continuing our chapter 10 from physics, okay. So today we are going to discuss the second part of this chapter. Actually, in first part of this chapter we already talk about the what is reflection, what is the types of reflection, the reflection, how the reflection is performed by the spherical mirror and the plane mirror. Then we already learn what is the image, what types of images are there, how these images are actually formed, right? Then what conditions are basically required for the formation of the image, okay. So along with this one thing, we also learn that the laws of reflection of light, clear, and we also learn the image formation, the ray diagram for the image formation by the spherical mirror, means both the two concave as well as convex mirror, how these images actually form, okay, when we place this object at the different positions on the principal axis, right, or in front of the mirror. Then we also learn what will be the nature of the image, where it will be formed, what will be the size of the image, okay, whether it will be real or virtual, clear. And we also learn that what is the use of this spherical mirrors, right. So now we are moving one step ahead, and today we are talking about the refraction of light, clear. And but before going to start the refraction of light, one thing is very compulsory, as you know that physics is the science of the measurement, especially, clear. So here is also just to decide the position, size, okay, and the distance of the object and the image, okay, it is compulsory to measure it, clear. So here to measure this one thing, some sign conventions are compulsory, okay. So first of all we are talking about the sign convention, okay. What will be the sign convention for the ray diagram, clear. So the sign conventions are what? According to the new Cartesian sign convention, the pole P, you know that what is the pole? The center point of the mirror, okay, from where the principal axis passes, that is the pole of the mirror, is taken as the origin, okay. Remember one thing, if you want to measure any distance, okay, then what will be the origin point? It will be always the pole of the mirror, okay. Then when we talk about the lenses, then later we will discuss that it will be the optical center of the lens, clear. Now the principal axis taken as the x-axis of the coordinate system, and the sign convention are as follows. So first of all, the object is always placed on the left of the mirror, okay. Suppose this is the mirror, then always that object will placed where? At the left side of the mirror. Then second, all distance parallel to principal axis are measured from the pole of the mirror. Suppose that this is the pole and this is the object. When you want to take the distance, then don't go from object to mirror, but go from the pole of the mirror to the object, right. Now all the distances measured to the right of the origin are taken as positive, while the distances measured to the left of the origin are taken as negative, right. This is the mirror on the principal axis. If anything you will measure left hand side of the mirror, then it will be always negative, and when any distance will measure where? At the right hand side of the mirror, that will be positive one, okay. The distance measured to the perpendicular to and below the principal axis are taken as negative. Again, principal axis, when the height is taken below the principal axis perpendicularly, then it will be negative, and the distance measured perpendicular to above and above the principal axis are taken as positive, and above the principal axis when it is perpendicular, then it is the positive one, okay. And the focal length of the convex mirror is positive, while the concave mirror is negative. What will be the reason? In this statement we said that always the focal length of the concave mirror will be negative, while the convex mirror is positive. Why? Right, because when we will measure the focal length of the concave mirror, then it will be always at the left hand side, clear, that's why it is negative, and the convex mirror, it is always right hand side, that's why it is positive. Okay, so with the help of this diagram we can make it very clear. Okay, so this is the concave mirror, this is the convex mirror, clear. Here you can see that this is the mirror, okay, and this is the reflective surface. Okay, it is painted from outside and this surface is used to reflect the light, that's why this mirror is a concave mirror. While what happened here, the internal surface of this curved glass material is painted and this outer surface is used to reflect the light, that's why it is a convex mirror and this is the concave mirror, right. Then here you can see that a light ray, an imaginary line is passes from the center of curvature to principal axis. So this straight line is actually passes from center of curvature to the center of the mirror, that's why it is called as the principal axis. Same here, from this center of curvature to pole of the curvature. Okay, so that's why this one is the principal axis, clear. As you know that this is the center of curvature, this is the pole of the mirror. Okay, so that's why what will be the focal length, it is always be the half of the which one thing, radius of curvature, right. Now then here you can see that now here this is the left hand side, this is the right hand side, clear. So whatever the distance when you will taking from pole to right hand side, that it will be positive. Okay, you remember when the object was placed between the focus and pole, okay, then the image was firm, it was virtual, erect, clear. Then the image will form where? Above the principal axis perpendicularly and behind the mirror. Then what will be the direction of distance? You will move from pole to right hand side of the mirror, that's why this position of the image will be positive. Okay, and the height of the image will also be positive. As we discussed earlier, whenever we will take the distance in the left hand side negative, right hand side positive, above the principal axis perpendicularly it will be positive and below the negative one. Okay, so this is the negative height and this is the positive height, clear. Now so suppose that if you want to take the suppose that this is the object which plays in front of the mirror, then what will be the distance of the object? To measure the distance of the object of this on this principal axis, you have to start, what will be the origin point? That is the pole. So you will move from pole to this position of the object. So this will be the which one thing? Right, it is the distance of the object, clear. This is the radius of the object from pole to center of curvature. This is the focal length of the object, this is from pole to focus. So this all 1, 2, 3, this all will be negative in nature. Okay, and because this object is perpendicularly placed above the principal axis, that's why it is also positive. But while this image will form below the perpendicular the principal axis perpendicularly, then it will be negative, clear. So what you observe, the focal length of concave mirror is always negative, while the focal length of the convex mirror is always positive, because it is always at the right hand side. Okay, just like that, when you will take the distance, focal length positive, okay, radius positive, clear, the image will form either this side, okay, so it will be always positive one. Okay, so this here you can learn about the sign conventions for the mirrors, and it is quite important to solve the numerical problem which is related with this all such measurements, clear. And remember, one of the question will surely comes in your final exams, which is based on the measurement of the mirror or the lenses. Remember this one thing. So do proper practice. We will take one example for the measurement and this one thing. Okay, now we are moving forward to derive the mirror formula. So first of all, we can define that what is the mirror formula. Okay, an expression showing the relation between object distance, image distance and focal length of a mirror is called as mirror formula. So what is the mirror formula? It is nothing special, it is just an equation which shows a relation between the focal length, okay, distance of the object and distance of the image. The relationship between these three will consider as the mirror formula. Okay, now just to derive the mirror formula, first you have to consider this diagram. Okay, here we are talking about the image formation, mirror formula derived for the concave mirror when the object is for the real image. Okay, now so you can see that this is the concave mirror. Here this M1 and M2 is the aperture. So you can say that it is the mirror. Okay, then this is the principal axis where this P is the pole. Okay, you can see that this AB is the object. Clear? It is perpendicularly placed above the principal axis. Okay, you know that to form the image at least two light rays you need to consider. So first of all, this AD is taken as a light ray parallel to the principal axis. Clear? Then after the reflection it will passes through the focus. So the point of intersection of this reflected ray along with this principal axis is called as the focus, right? Now then take the second light ray, clear, which is passes through the center of curvature. This is A, okay, and it struck this mirror here, and because it passes from the center, then without any deviation it will reflected back with the same angle, that is the 0. So that's why you can see that this reflected ray from the D point and this reflected ray will intersect here only. So you will get the image where in front of the mirror it is inverted, okay, it is small and it can be obtained on the screen. So that's why it is the real image. Clear? Now so this is the basic fact about this one thing, and here this C point is taken as the center, AF is taken as the focus, and this A dash B dash is the image. Okay, and on point B this image is actually formed between the center and the focus. Clear? The next one thing, here we need to draw a perpendicular DN on the principal axis near the mirror. Okay, in fact this mirror is a concave mirror, but it seems that it is a parallel one because its surface is nearly parallel. Okay, it's a plane. So that's why there is no difference between the P and N point. It will consider that they are coincident on the same point, which is N and P. So whatever the distance you will take from P or N, it will consider as the same one. Okay, now so just like that, just see this diagram and conclude few facts. What will be the distance of the object? Yes, the distance of the object will be PB. Okay, it will be negative or positive? Right, it will be negative one. Clear? What will be the radius? This is the PC. This is actually denoted by capital R. Okay, it will also negative, so this PC will be minus R. This PB will be minus U. The distance of the object is always denoted by U. Okay, now small u. Then this is the focus. PF is the focal length and it is also negative, that is minus F. Clear? And this is the object image distance PB dash. It is represented with the V. Okay, and it is also negative one. Clear? And this is the pole. Okay, remember this is the DN is perpendicular on this one thing. Okay, now and this is the size of the object B dash A dash. Clear? So remember these facts in your mind, then it will be easy to substitute the values, replace the values and put the values in the equation. Okay, so now first of all we already learned that what is the mirror formula. Then now we are going to derive this mirror formula. Okay, so this M1 M2 is the concave mirror having pole P, focus F and center of curvature C. We already learned from this one thing. Then an object AB is placed in front of the mirror with point B on the principal axis and the image formed by mirror is A dash B dash and the perpendicular drop from the point of incident D on principal is DN. Clear? So the object is AB and the image is A dash B dash. Okay, this AB is parallel to DN. Clear? And this A dash B dash is also parallel to DN and along with the AB too. Clear? Now, so here we are considering triangle ABC. Just see that this ABC and A dash, B dash, C dash both are which angles? Right angles. Okay, and both these triangles are similar. Okay, so these two triangles are similar, so that's why here you get why it is similar, because ABC and A dash, B dash, C dash, these triangles are equal in nature. Okay, and next one thing, this is the ACB and here is the A dash, C, B dash. Okay, if these two triangles are similar, these two angles are similar of the two different triangles, then these two triangles ABC and A dash, B dash, C will be what type in nature? Similar. So by keeping this thing in our mind, we are moving forward. Okay, so here we are deriving this first equation. Okay, just take the parallel parts, AB upon A dash, B dash. Okay, this is the perpendicular of the height of the object upon height of the image. Clear? That's why this will be equal to BC upon B dash C, right? So this way you are getting the first equation. Okay, this upon this is equal to this upon this. Okay, now we are taking the next triangle, that is the DNF. Okay, which one? DNF. Clear? And the second triangle is, that is the A dash, B dash, F, and these two are also similar because angle DNF and angle A dash, B dash, F, okay, as well as NDF as well, A dash, F, B dash, these two angles of the two triangles are equal. That's why these two triangles are similar. Just we are taking the same one. Okay, which one thing? That is DN upon A dash, B dash. Okay, similarly which one thing? FN upon FB dash. Clear? So this is the second equation. Clear? Now here we can see that these two lines, okay, which one thing? BN as well as AD, these two are parallel to each other. Okay, and AB and DN, these two are the perpendicular which dropped from AD on the BN. Clear? So that's why this AB and DN will be equal as well parallel. Okay, so in this equation DN can be, see that this DN can be replaced by AB. Okay, so just this replace DN by AB, then you will get this equation. Okay, AB upon A dash, B dash is equal to Fn upon B dash, F. Clear? So you will get the second equation. Now when we compare this equation 2 and equation 1, so what do you observe here? Just see the left hand side of this one thing, AB upon A dash, B dash, here is also AB upon A dash, B dash. If these two are equal, so that's why BC upon B dash C and Fn upon B dash, F will be equal. Okay, so that's why by using this one thing, we are having the next equation 4, that is BC upon B dash C, okay, is equal to Fn upon B dash, F. Clear? Now, so this way we are having this equation. Clear? Now just replace these values BC. Okay, you can see that BC is replaced by PB minus PC. Okay, so where is the BC? This is the BC. Clear? And how it is replaced? It is replaced by PB minus PC. See that this BC. Okay, how can we replace? Just take the difference PB minus PC, then you will get the BC. Okay, so here you can see that this BC is replaced with this PB minus PC. Okay, and this FP, which one thing? This FP is common in both the two one because it is the least distance, it cannot be replaced by anyone. Okay, similarly here we can replace B dash C. Okay, B dash C, how can you will replace? This B dash C can be replaced by PC minus PB dash, so you will get B dash C. Clear? So this one, and B dash F, this B dash F can be replaced PB dash minus PF, so you will have BPF. Clear? So this is the values which can be replaced by this one thing. Okay, so by sign conventions, if you observe PB, what is PB? PB, distance of the object, it is denoted by U, and it is taken where? At the left hand side of the mirror, that's why it will be -1, right? Now second one, that is PB dash, this PB dash, this is the distance of the image. It is also which side? Left hand side of the mirror, so it is also negative 1. Image distance of the image is denoted by V, so it is minus V, right? Now focal length F, clear? This focal point is F, so PF is also negative. It is also denoted by F, so it is minus F, clear? So now, and what is the radius of curvature? Radius of curvature is PC, okay? It is denoted by capital R, and it is also which side of the mirror? We are taking this distance again at the left hand side of the mirror, so that's why it is also negative, so it is minus R. And what is the relation between the focal length and the radius of the curvature? Just tell me. Right, you are right. The relation is radius is always twice of the focal length, okay, and focal length is always half of the radius, clear? So this minus R is equal to minus 2F. Now just keeping this equation number 4 in our mind, okay, we can replace by this one thing, okay? Then like this, PB is replaced by minus U, PC is replaced by minus 2F, because PC is the R and R is the twice of F, clear? Then again this PC is replaced by which one thing? 2F, PB is replaced by minus V, and here PF is the minus F and PB is minus VU, okay? So just by taking negative is the common one, okay, we are getting this equation, that is 2F square minus VF is equal to minus UF plus UV plus 2F square minus 2FV, clear? So just by transposing this one thing, when you will take this one, then this 2 will be cancelled, and when you carry this one thing, then VF will be positive, it will goes to this side, then it will be the positive one, and UV remain this side. That's why you are having which one thing? UV is equal to UF plus VF, clear? Now what is the next step? Just divide all these three values with the help of UVF, that means right hand and left hand side of this equation is divided by UVF, okay? So FV upon UVF, UF upon UVF and UV upon UVF, then you will get 1 upon U plus 1 upon V is equal to 1 upon F. So this is the mirror formula which we actually required, okay? So again, what is the mirror formula? 1 upon F is equal to 1 upon V plus 1 upon U. Three values are there, okay? So with the help of this one thing, you can consider and find out the value of any missing quantity, okay? So remember this one. So many questions are there in your textbook, in your references, okay, in your exemplar, NCERT exemplar. You have to solve it, and you can identify the nature of the image, object, nature of the object, height and all such things, clear? Here I am solving one example, okay, just like that. What is? If an object is placed 10 centimeter from a convex mirror of radius of curvature 60 centimeter, then find the position of image. So when you will have this question, then immediately focus on few facts. First of all, you have to find out what is the nature of the mirror. So what is the nature of the mirror? It is convex mirror, okay? Then this object will place where? Right hand side, left hand side of the mirror. That's why the distance of the object is 10 centimeter. That means it is U and it will be negative. So the distance of the object U is 10 centimeter negative, clear? Then what we learn in the sign convention, whatever the distance we are taking where? At the right hand side of the mirror, it will be positive, clear? So the radius of curvature will be positive, that was 60 centimeter. That means R is plus 60, okay? Then find the nature and the size of the position of the image, clear? What is the position of the image? You have to find out V. So what is given here? Position of the object is given, radius of the curvature is given. So with the help of radius of curvature, by using that formula, R is equal, F is equal to R upon 2. So 60 upon 2 is equal to 30, right? So you are having which one thing? U and F. So you can find out V, clear? Just place this value here, okay? That is 1 upon 30 minus 1 upon 10, so you will get 4 upon 30, this is 1 upon f. So what will be the f? Just inverse the value, 30 upon 4, it will be 7.5, clear? So what will be the value of this one thing? See that it is positive or negative? Positive, right? So where it will be? It will be at the right hand side of the mirror. That means it will be virtual, right? Remember this fact, okay? So many things you can conclude from this one. Okay, now here we are going to discuss one more fact, that is the linear magnification. Clear? What is the linear magnification? The linear magnification produced by a spherical mirror is the ratio of the size of the image formed by the mirror, so that of the size of the object. Okay, simply what will be the formula? That is the height of the image divided by height of the object. So you will get the magnification of the image. Clear? So it is expressed as the ratio of the height of the object and the height of the image. Clear? Yeah, or you can say that the magnification is also related to the object distance and the image distance. Okay, that means on the place of, if it is not given, which one thing? The height of the object and height of the image is not given. Okay, so just remember these two are parallel to each other. So you can make one more formula, that is minus v upon u is equal to hi upon ho. What is hi? Height of the image and height of the object. So this with these four values when placed with parallel to each other. Okay, so if anyone is missing, then you can find out. Okay, so remember this fact, it will be helpful to find out the values of any one of this one which is given in your question. Okay, so remember this one thing, so it will be easy to solve the related numerical problems. Okay, now few facts are given here in the tabular form, from which how can we draw the conclusions. Okay, just like that, here this magnification is given, okay, along with the sign. If magnification is equal to 1, then what you consider? You can conclude that the height of the object and height of the image is equal. They are equal in height. Okay, then if magnification is less than 1, okay, if magnification is less than 1, then what will be the size of the image? The size of the image will be shorter than the height of the object. Clear? If magnification is more than 1, then what will be the conclusion? The height of the object is smaller than the height of the image, or simply you can see that height of the image is greater than the height of the object. Okay, so just by keeping these three facts in the mind about the magnification, you can consider the size of the image, right? Then here this sign along with the magnification is also important to conclude about the nature of the image. Just like that, if this value of the magnification is given as a negative one, okay, then what is given here? The image will be real and inverted. What is the meaning of the real and inverted image? It will be always firm in front of the mirror and it is always perpendicularly downward the principal axis, right? If this positive sign is given along with the value of the magnification, then what will be the conclusion about the image? It will be virtual and erect. What is the meaning of the virtual and erect image? The image will always form behind the mirror. Okay, and what is the second fact? It will be always erect. Okay, so remember this fact along with this sign and the values. Okay, now here one more numerical I want to consider for this magnification and height of the object and image. Clear? See that an object is placed at a distance of image in front of a concave mirror. Remember what is the object is placed where? In front of the concave mirror. Then what will be the nature of the mirror? It will be converging. Clear? Then it forms a real image. Again, real image, it is forming where? In front of the mirror. Okay, and 4 times larger than the object. What is the size? 4 times larger the object. Clear? Then calculate the distance of the image from the mirror. So you have to find out the distance of the image from the mirror. Okay, if you observe that, then distance of object is 12 centimeter. Okay, that is the minus 12. Okay, the magnification will be minus 4. Okay, so it is taken as minus v upon u, then therefore you will have a minus 4 is equal to minus v upon minus 12. It will passes to this one, then 12 4 is 40, 12 4 that is the 60 centimeter. Okay, it is wrongly by mistake it is written there, so remember this one. Okay, so this way we can find out the image and object position in this one thing. Clear? Now one more fact, how can you will find out the nature or the identification of the mirror? Clear? So see these few facts are given. By observing the image produced by a mirror for different position of object, its nature can be identified. How? If the image formed by the mirror is of same size as that of object for different position of object, then the mirror is a plane mirror. What will be the qualities and the characteristics of the image formation by the plane mirror? It is always virtual, it will always be erect, it will always be equal in size, and it will always be equidistant from the mirror. Okay, in response of the position of the object. Clear? So if these qualities are given, then this mirror will be plane mirror. Now if the image formed by the mirror is diminished for all the position of object, then the mirror is convex mirror, because image is always smaller than the object behind the mirror. Okay, now if the image formed behind the mirror is longer than the object, then the mirror is concave mirror. Remember, in this case the image is virtual and erect in nature. Okay, now so this is all about the image formation by the concave mirror and the reflection by the concave mirror. Now here we are going to discuss the next phenomenon, that is called as refraction, not reflection, it is the refraction. Clear? Reflection is performed by a totally shiny opaque surface. Now this refraction is performed by the transparent surfaces. Okay, so what is the refraction of light? Change in path of a light ray as it passes from one medium to another medium is called refraction of light. Okay, and the bending of light are interface of two different medium is called the refraction of light. Simply, when the light is moving from one medium to another medium, then it will just displace from its actual path. Okay, it will bend it from its position. Okay, so it is considered as the refraction. That means fractionization of the light ray when it passes from one medium to another one. Clear? Simply, if the velocity of light in medium is more, then the medium is called optical rarer medium. Okay, there are two type of medium. One is rare medium and second is dense medium. Okay, so what is the dense? When the component of that medium is in very dispersive form. Clear? They are not very densely packed. Clear? That is called as, and surely the speed of the light will be greater. So this is the rare one, just like the air or vacuum. Okay, it is called the optical rarer. If the velocity of light in medium is less, then the medium is called as the optical denser. Likewise, when you compare the glass in comparison of water and air. Okay, now the refraction of the light is the phenomenon of change in the path of light in going from one medium to another medium. One more way we can see like this one. Okay, so in going from a rarer to denser medium, the ray of light bends toward the normal, and going from a denser to a rarer medium, the ray of light bends away from the normal. Okay, so here these two diagrams are given. Clear? This is the surface of incidence. Okay, this is the rarer medium, this is the denser medium. Clear? When this incident ray falls on this point of incidence, okay, then it is moving from rarer to denser, then according to the refraction, okay, it will bend towards the normal. Okay, so this angle is considered the angle of incidence and this angle is considered the angle of refraction. Clear? Then in this condition always the angle of refraction will be smaller than the angle of incidence. okay, just opposite with this. In this case, when light is moving from denser to rare, such that it is moving from glass to water or it is moving from water to air, then this condition will be there. Okay, this is the incident ray, this is the normal, this is the point of incidence, then surely on the place of going this straight one, it will move away from the normal. Okay, that means the angle of refraction will be greater than the angle of incidence. Okay, so remember these two facts about the refraction of light. Whenever the light move from rare to denser, it will bend toward the normal. When it will move from denser to rarer one, then it will move away from the normal. Okay, now here we are going to discuss about the cause of the refraction. Clear? So the speed of light is different in the different medium. So it is lesser in denser medium and higher in rarer medium. Remember this one fact about the speed of the light. Clear? So when the light enters a denser medium, its speed reduces and it bends toward the normal, and when it enters rarer medium from the denser one, then its speed will be increases and it bends away from the normal. Okay, so this is the reason why the bending of the light is observed. Okay, now when the speed of light will decreases, then it will bend toward the normal, and if the speed of light will increases, then it bends away from the normal. Okay, so in your everyday life you find so many examples related with this refraction of light. So here we are trying to learn about these two facts. Okay, just like that, one thing is very common. When you dip a pencil or a wooden stick or the scale partially in the water, then you will observe that it appears bent in nature. Okay, similarly, if you drop a coin in the transparent glass container, then when you observe it from the top, then you will observe that it seems that it raised upward, okay, from its position. So what is the reason behind it? We will just try to find out this one thing. It is nothing special, it is not a magic, okay, it is just a phenomenon related with the refraction of light. Clear? Have you ever visited the glass house? Okay, in this glass house, if you observe that so many funny images will form by the different mirrors and the lenses there only. It is nothing special, it is just a phenomenon related with the refraction and the reflection of light. Clear? So whenever you go to any such this kind of places, just try to find out the reason behind it. Okay, now so here you can see that this is a glass container filled with water, half with water. Okay, and this is a pencil which dipped in water. Okay, so what happened? From this point, okay, you just take this two different light ray which is just raising from this point. Clear? This one and this second one. So what happened? This is the point of incidence, and what you observe, the light is moving from denser to rarer medium. Okay, so if you will drop these two normals or perpendicular at the point of incidence, then what will be the bending of light? Yes, right, it will bend away from the normal. Okay, so when it bends away from the normal, but is not going to intersect here, so you need to extend it backside. Okay, so they will meet here, so the position of the object will observe here. Okay, that's why this pencil will appear bent as well as it will raised here. Okay, similarly, this coin which is placed here at the bottom of this glass container, just take this two light ray from this one, this is the point of incident, just draw this two normal. So on the place of bending towards the normal or going straighten, it will bend away from the normal. So when you extend it backside, then you can see the image of the coin above the position. Clear? So this is a good example. Okay, some other examples are also there. If you drop a drop of water on the printed paper, okay, so this letters which is on the paper, it seems larger in size, bigger in size. Okay, similarly, if you will take a lemon, okay, and dropped in a glass container and observe it out from outside, then surely it will appear bigger in size. Clear? So now the tracing the path of a ray of light passing through a rectangular glass slab. So these points can be considered here only. Clear? So for this one thing, procedure is there. Okay, just take a which one thing, a soft drawing board. Okay, fix a A4 size paper on it properly. Okay, then just put this glass slab. Okay, which one thing, that is PQ or S in the middle, and just draw its boundary. Clear? Then just remove this glass slab and take this point as a point of incidence. Draw a normal here. Okay, and then just by taking this as a base and as a vertex, just draw an angle of 30 degree. Okay, so this will be, AB will be incident ray, this angle will be angle of incidence. Clear? Now just take two alpines and fix them here perpendicularly on this incident ray as point A and B. Clear? Again relocate or replace this glass slab in this boundary. Okay, and just from this side, okay, take one more alpine and fix to align with this AB light ray. Clear? So you will fix it here C and D point. Clear? So now just when you observe from this side, then this DCBA, it seems in a straight line. Clear? Remove this glass slab and just join this 2 1 with this point, so it will be the point of incident. Clear? Just draw the normal, just join these 2 points. Clear? So you will have, this is the incident ray, this is the refracted ray, and for this two medium it will be incident, this is the refracted, or you can also call it, it is the emergent ray. Clear? So here this is the angle of incidence, this is the angle of refraction, this is the angle of emergence. Clear? This is the first normal, this is the second normal, and this is the actual path of the light ray. But what you observe, on the place of going through this light, this path, you may observe it from this one. So this one banding or this much distance is observed, it is called as the lateral displacement of the light ray. Clear? So just take the next example. For the next value, on the place of this 30 degree, increase this value with the 45, then with the 60 degree, and just consider the angle of this refraction and this one thing. Okay, so when you consider this one thing for 30, 45, 60, you observe that the angle of refraction is 28, 43 and 56. Okay, and the angle of emergence is, it will be always equal. If this is 30, then this 30, 45, 44.8, 60, 50. It is the human nature, or the human mistakes are acceptable. It is just very few. Okay, so this deviation is observed, but almost all this is the constant one. Clear? So what conclusion which we can draw? The angle of incident and the angle of emergence are almost equal. Second thing, as the light is traveling from rarer to denser optical, the angle of refraction will be lesser than the angle of incidence. Okay, for different angles of incidence, the lateral displacement will remain the same. Okay, and the light will bend toward the normal when it travels from an optically rarer medium to an optically denser medium. Okay, remember this fact, which we can conclude from this one thing. When you will come back to school, then we will perform this experiment in the laboratory also. Okay, so here we are going to discuss the laws of refraction of light. Okay, so what are the laws? The incident ray, the refracted ray, and the normal to the interference of the two transparent medium at the point of incidence all lie in the same plane, just like the law of reflection. Okay, and the second, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is always a constant. Clear? For the monochromatic light, remember monochromatic light, because the wavelength of the light is different, so that different colors is different, so that's why it will give the different result. Okay, so this law is also called as the Snell's law of refraction. Remember, the ratio of the sine I and the sine R, that is the value of the angle of incidence and the angle of refraction, will always be a constant. It will consider the mu or n. Clear? Remember, these are the two laws of refraction of light. Now here we are going to discuss the refractive index. One more important feature, the extent to which the light bends when moving from one medium to another is called the refractive index. So what is the refractive index? The ratio between the angle, okay, of the two medium. Clear? This depends on the ratio of the speed in the two media of light. Clear? The greater the ratio, more the banding, and it is also the ratio of the sine of the angle of incidence and the sine of the angle of refraction, okay, which is constant for the given pair because it will follow the Snell's law, okay. So here mu 1 upon mu 2, that is sine I upon sine R, the value of angle of refraction, incidence upon value of refraction. So here it can be considered speed of light in medium 1 and speed of light in medium 2. When you will consider this 2 1, then you can find out the refractive index. Now here we are going to discuss the absolute refractive index. What is the difference between the absolute refractive index and the refractive index? Refractive index is simply the ratio of the speed of light in any two corresponding medium. But when we talk about the absolute refractive index, then surely the first medium will be rarest one, that is the air or the vacuum, okay. Basically we are considering the vacuum, but practically it is impossible, so always we are taking is the air one, okay. So refractive index of one medium with the respect another medium is called the relative refractive index, and when taken the respect to vacuum, it is called as the absolute refractive index. So that's why here the speed of light in vacuum or air and the speed of light in the corresponding medium will consider the refractive index. Clear? Now here we are going to discuss one more very important and somewhat different type of phenomenon, that is called the total internal reflection, okay. You just till today, I think so, you just learn about that when light ray passes from one transparent medium to another transparent medium, it will only bend, that means refraction. But here reflection is also possible, okay. So how is it possible? Just consider this is the rare medium and this is the denser medium, water, okay. So just consider this light rays start from water to air, okay. So the point of incidence, if you will drop a normal here, then surely it will bend away from the normal because its speed will increases here, okay. Just consider second one. If you will increase the angle of incidence, of course the angle of refraction will increases, okay. So the value for which one? This incident angle, the value of angle of refraction is 90 degree, is called as critical angle. So this angle is critical because it is responsible to deflect the light by 90 degree. Clear? Now what happened next? If you will increase the value of this incident angle more than this critical angle, then on the place of following the law of refraction of light, it will follow the law of reflection of light even though these two mediums are transparent, okay. So when the value of angle of incidence will increases than the critical angle, then on the place of showing refraction, it will show the reflection, okay, and you will get this value, okay. So here this total internal reflection is there. In the latter part of this, in our latter part of the discussion, we will talk about the example related with the total internal reflection. You heard about the mirage formation. I think so. You also knows about the appearance of this. Which one thing, that is the igloo and this one in the sky, okay. So we will talk about later in later portion, okay. So finally I would like to express my hearty thanks to all of you to listen me carefully, okay. Just beta remember this topic is very important from your examination point of view, because surely one question for numerical values will come. So thank you, all the best, keep reading.